Transformations of functions. As you advance through higher math courses, it becomes useful to be able to make quick sketches of graphs without plotting points or using a graphing calculator. Some common functions in their basic forms, called parent graphs, should be memorized. And so these are 6 that we'll be using today. The first one is linear, y equals x, that just makes a straight line. Then quadratic, y equals x squared, is a parabola. Absolute value, y equals absolute value of x, it makes a v. I always remember v for value. The cubic, y equals x cubed, is the smile on the right side, frown on the left side, is an easy way to draw that. Square root, y equals x, square root of x starts at 0, 0 and curves slightly up. And then the cube root, y equals the cube root of x, and you can see how that's kind of a wavy little thing there. When numbers are added, subtracted, and or multiplied to the parent graphs, the graphs move, rotate, and stretch or shrink. And so there is a worksheet in your notes that has this display on it, and it's called Graphical Transformations, and so it's good to have to refer to throughout the lesson and throughout your homework. And this formula applies to all the parent graph functions, and it's helpful to identify A, B, C, and D in each problem. Not every problem will have all of those. In fact, for your book, they don't do the horizontal stretching or shrinking at all, so you don't have to worry about the letter B for what we're doing today. So we'll talk about all of these things. If something is on the outside of a function, it's vertical and it behaves as you would expect. If something is inside the function, it's horizontal, and it kind of does the opposite of what you would expect, and we'll talk about that as we go through. So these are some transformations where we're shifting things up and down. On the first graph is just the parent graph of y equals x squared, and then you can see that the next one, x squared plus 2, the plus 2 is outside of the x squared, so that would be the letter D in our formulas. And if it's a plus, it goes up. So this parabola is moving up 2 and redrawn. The next one is a minus 2. Again, that's the D. And if D is negative, that means you're moving down 2. Then we start over again. And if something is added or subtracted inside, it moves the graph left and right. But it's backwards of what you would think. So look at y equals x plus 2 in parentheses squared. That 2 would be the letter C in our formulas. And plus actually moves things to the left. So that one, parabolas move left 2. A minus 2 on the inside, again that's the letter C, moves to the right. So that's backwards of what you would think. When a negative is multiplied on the outside of the function, the graph will flip vertically. So you see the parent graph of the square root of x, and then we put a negative out front. That makes a vertical flip, an up-down flip. So the graph flips over. If it's on the inside, if the minus is on the inside of the function, then it's a horizontal flip. That's a left-right flip. Now, when you have a number multiplied to the function, it causes a stretch or a shrink. So when a number, which we'll call a, is multiplied on the outside of a function, you have a vertical stretch if a is greater than 1 and a vertical shrink if a is less than 1. So on these examples here, 4 would be the a. 4 is bigger than 1, so it's a vertical stretch of 4. And a vertical stretch pulls straight up and straight down on the graph. And so it's going to make it more narrow. It's pulling from above and below. Think of the graph as being your arms and somebody's pulling from above and below. It'll make your arms move closer to your body. If the a is less than 1, that's a vertical shrink. So this is a vertical shrink of 1/4. Vertical shrink means that you're pushing down from above and below, which makes the graph kind of bow out, so it becomes more wide. So we're asked to use transformations to sketch the graph Make sure you also write the transformation. Say how the graph is changing. On this first one, f of x equals 4x squared. That 4 would be a, because it's multiplied on the outside. It's greater than 1, so it's going to be a vertical stretch of 4. And you need to actually write those words, vertical stretch of 4. Now when we draw it, first draw the parent graph. A vertical stretch pulls straight up on the graph, and it's going to make it more narrow. And so that I can tell which one is your final answer, put little stars by your final answer. I have to have both the original and the stretched one drawn, or I can't tell if you made it more narrow or more wide. When you're moving things left, right, up, and down, you don't necessarily need to draw the original and the new one. But when you're stretching or shrinking, you have to. I have to see the original and the new one with stars beside it. This one says h of x equals the absolute value of x plus 2. You have something added on the inside of the function, that would be c. Because it's plus, that means we're moving it to the left. Absolute value is a v. And because we're not doing any stretching or shrinking, it's okay just to draw the new one. So it normally is anchored at 0, 0. It's being moved left 2. And so there's our new graph. P of x equals negative square root of x plus 3. The negative on the outside means a vertical flip. Plus 3 on the outside, that would be d, and plus is up, so it's up 3. And again, you've got to write these things down. I have to see in written words the transformation. And then to draw it, it's the square root graph, which normally is anchored at 0, 0 and slopes up a little bit. So it's being moved up 3 and then flipped over vertically. So the new graph would look like this. If you need to draw some intermediate steps in between, that's fine. But since we're not stretching or shrinking, you don't have to. So it moved up 3 and then it flipped over. R of x equals 3 times x minus 1 all squared plus 2. So 3 would be a. The 1 would be c, and 2 would be d. 3 is greater than 1, so that is a vertical stretch of 3. The minus 1 on the inside means we're moving to the right 1. And the 2 on the outside plus 2 means we're moving up 2. When you've got several things involved here, always save the stretching or shrinking for last. Do that last. It's an x squared, that's a parabola. And it's moving right 1 and up 2. So it's normally anchored at 0, 0. We're scooting that right 1 and up 2. And then it's a vertical stretch, so it's going to become more narrow. So I need to draw a second one to show that I've stretched it rather. Now it depends on the size of the number, how narrow it becomes. The larger the number, the more narrow. And so we're not really interested in getting exact graphs. We just want a general sketch. So even though, if it was a 10, it'd be even more narrow and all of that, we're not going to be that exact. So just get a sketch of it and then you're good. F of x equals the square root of negative x and then minus 1. The negative on the inside means a horizontal flip. The 1 would be d. It's a minus, so it's down 1. Okay, square root graph, it's getting moved down 1 and then flipped horizontally. That's a left-right flip. So that would go this way. And then one more. 1/3 on the outside, that would be the a. It's less than 1, so that is a vertical shrink of 1/3. And because I have a shrink, I've got to draw the original and the new one. So absolute value is a v. Vertical shrink means we're pushing down from above. If those were arms, then they're going to go wider. So here would be my new one, and put stars to show that that's the final answer.